Hello guys, good morning, good evening, good afternoon, wherever you are seeing me on the globe. Today we are just going to do some sample equations here in as far as chemistry mole concept is concerned. So we have been given here on the wall that 25 cubic centimeters of 0.1 molar hydrochloric acid is completely neutralized to 25 cubic centimeters of sodium hydroxide. Write the equation for the reaction. In this case, we are just going to deal with sodium hydroxide and hydrochloric acid. So we are going to write the equation to answer Roman 1. So we are going to write this. Sodium hydroxide plus hydrochloric acid, it gives us sodium chloride plus water. So after you have written this, the equation is not properly balanced and we have not indicated all the states as it's supposed to be done. So we are supposed now to write on the product side, this is liquid, this is an aqueous, and then also this is an aqueous, this is also an aqueous. So the equation is properly balanced. When you count the number of atoms of sodium hydroxide on the reactant side, sodium is here, sodium is there, also another one atom. Oxygens, how many oxygens on the reactant side? We only have one oxygen. We also have one oxygen. Hydrogen, how many hydrogens do we have on this side? We have 1, 2. So on the reactant sides we have 2 hydrogens, and also on the product sides we have what? 2 hydrogens here. So we have written this is an aqueous, and this is the liquid. So chlorines, how many chlorines do we have? We have 1 chlorine on the reactant side and 1 chlorine on the product side. So the equation is balanced. So we go to question 2, question Roman 2. Write the moles of hydrochloric acid. So we are just going to calculate the moles. Calculate the moles of hydrochloric acid. So in this case, we must also write the equation first so that it can be able to guide us in our calculation. So we are going to write this equation, sodium hydroxide plus hydrochloric acid, it's going to give us sodium chloride plus water. So you always remember to write the states in which the compound is in after the reaction and before the reaction. So in this case, we are going to ask ourselves, what is the mole ratio between the reactants? It is 1:1 after we have gotten the products. Now, we are going also to write the molarity, and the volume. So in this case, we have been told it is sodium hydroxide. We have not been given the molarity of sodium hydroxide, but we have just been provided with the volume, and also we have been given the molarity of hydrochloric acid. So we are going to write here the molarity, it's X, and on this side it is 0.1. This side we have been given 25 cubic centimeters. So you come and write just here 25 cubic centimeters, and then on this side we have also been given 25 cubic centimeters. So we have been asked to calculate the number of moles. Calculate the number of moles. The number of moles of hydrochloric acid. So we are just going to ask ourselves this question. Since they want the number of moles of hydrochloric acid, we are going to say this is molar. If 0.1 moles are in 1,000 cubic centimeters, what about How many moles are there in 25 cubic centimeters? 25 cubic centimeters. So in this case, we are just going to cross multiply. We are going to cross multiply 0.1 times 25 over 1000. So we are going to write 0.1 times 25 cubic centimeters over 1000 cubic centimeters. So if you do your mathematics clearly, you will just get something to do with the 0.0025. 0.0025 moles. So we go to question 2. Question 3. Calculate the molarity. We write here calculate. This is Roman 1, 2, Roman 3. We have been told to calculate the molarity. Calculate the molarity of sodium hydroxide. So in this case, we are going to write the equation hydrochloric acid plus sodium hydroxide. It's going to give you sodium chloride plus water. This is liquid, this is aqueous, also this is aqueous. So we have been told to calculate the molarity of sodium hydroxide. So we are going to ask ourselves, if sodium hydroxide has this number of moles, because the mole ratio is 1:1, so the number of moles of hydrochloric acid with sodium hydroxide, they are the same. So that's why I'm saying if sodium hydroxide has 0.0025 moles, what about we are going to ask ourselves, if 25 cubic centimeters, this one, 25 cubic centimeters of this, completely neutralized, 25 cubic centimeters has got this number of moles. This number of moles. What about 1,000? 1,000 cubic centimeters. So we are going to cross multiply also, so that we can get 1,000 cubic centimeters times 0.0025 moles over 25. If you can be able to do your mathematics very clearly, you will come up with 0.1 molar. We have answered that question. Roman 4. We have been told to calculate the concentration of, calculate the concentration of sodium hydroxide. Sodium hydroxide in grams per liter. Grams per liter. In this case, we are just going to ask ourselves molarity is equals to mass in grams per liter divided by the RFN. So in this case, we are going to have this. We are going to substitute and get this. We are going also to calculate the relative formula mass of sodium hydroxide, because it is the one that we are supposed to substitute under this. So we are going to ask ourselves, sodium hydroxide is equals to sodium relative atomic mass in this compound, 1 times 23, which is giving us 23. Oxygen has 16. So it is just one atom in this compound. It is only one atom. So we are going to get to multiply 1 times 16, giving us 16. Hydrogen is only also one atom. So it's going to give us 1 times 1, which is giving us 1. So when you do your calculations properly, you will find that it is 40 grams. 40 grams. So we are going to substitute here, because molarity we have already calculated that it's 0.1. So we are going to substitute in this formula to get, if 0.1 molar is equals to, we are doing a substitution. 0.1 is equals to Y grams per liter over the RFM, which is 40. So we are going to cross multiply. Let's make Y the subject of the formula. The subject of the formula. So we are going to substitute and get, we multiply both sides. If we can be able to substitute, we are going to get something like this. Y over 40. So for us to make Y the subject of the formula, we must multiply both sides by 40 so that we can remain with Y. So we multiply this side by 40 and also this side by 40. So that we can get Y. Therefore, Y is equals to 40 times 0.1, which is giving us 4 grams. 4 grams per liter. So it is only 4 grams that were dissolved in a liter for us to come up with 0.1 molar. For those few remarks, remember to like, to subscribe, and also to share, so that we can be able. Also make some comments. See you next time, and I hope we will continue with the next virtual practical class. Thank you for listening to me. Thank you. Bye-bye.